Okay, here's another quick example of a work problem. This time we've got a 3 kilogram box and it's being pulled by a force F over a distance of 6 meters. This time we're going to work with a variable force. So the force is going to vary with the distance right here. And then the question is going to be, what's the final velocity? I guess we should put that the initial velocity is 0. Okay, so how do we figure out the final velocity? Once again, it's going to be work is going to be a change in kinetic energy problem. And this time work, we're going to have to do the integral form of work. So that's going to be the integral of F dx. So now we just have to take this equation for our force and stick it inside of there. So that's going to give us the integral of 3x squared dx. And I know some of you are still just kind of learning the integrals thing. We're going to evaluate that from 0 to 6. Pretty easy integral to do, so I'm looking for what function, if I take the derivative of it, gives me 3x squared. So that's pretty easy. That's just going to be x cubed, because if I take the derivative of x cubed, I get 3x squared. And then we're going to evaluate that from 0 to 6. And that's just going to give us 6 cubed minus 0. And that is 6 cubed. I did it before. Let me see. 6 times 6 times 6. 216. 216 joules. Good. Now that we know the work, now we can just use our good old work equals change in kinetic energy. So this is going to be work is change in kinetic energy. That's 1/2 mv final squared minus 1/2 mv initial squared. Since we don't have an initial velocity, we just have this. So I get 216 is 1/2, where's my mass, is 3 times v final squared. And then v final is, I worked it out before, this turns out to be 12 meters per second, which is also reasonable. So note that this time we can't actually use our other equation. The v squared is v0 squared plus 2a delta x. This equation won't work because we don't have a constant acceleration. Not constant. We don't have a constant acceleration because we don't have a constant force. So you cannot use this equation down here in order to figure out this problem. Really the only way, not the only way, but the easiest way to do it is with work. And the other way we could potentially do it is to think about what the acceleration would be as a function of distance as well. And that just becomes kind of a pain. So we would have a non-constant acceleration, which would mean that our position formula would be cubic. It'd be something times t cubed, and then you'd get your 1/2 at squared equation in there also. Hold on, let me boost that down. So you'd get something times t cubed, and that would just be kind of a pain to do. So anyway, that's that.